Okay, so this is going to be graphing piecewise functions set number 2. So when we graph a piecewise function, we're going to make a t-chart. So we make a t-chart for the top branch, and we're going to make a t-chart for the bottom branch. Oop. Okay, so like that. Okay, so for the first branch, we're going to pick values that are less than or equal to 0. So starting at 0, -1, -2, -3, -4. And I'm going to plug in 0 gives you a 1. -1 times a -1, so it goes 2, 3, 4, and 5. Okay, now we're in the equal to branch, so this is going to be closed. Okay, now we're going to pick values starting at 0 and 1, 2, 3, and 4. Now, like we did before, we're going to plot the good points when we go to graph this. So plug in a 0, you should get a -4. Plug in a 1. Let's see, 4/3 -1. Oh, wait, sorry, 4/3 minus 4 is -8/3. Okay, so plug in a 2, you get 8/3 minus 4, it's a -4/3. Plug in a 3, you get 0. Okay, and you plug in a 4, you should get 16/3 minus 4, it's 4/3. Okay, so this is going to be an open point at 0 because it's not equal to. Okay, so when we go to plot these points, so 0, 1, it's going to be closed. -1, 2. 3, 4. Okay, so it's going to look like that. Something like that. Okay, and then we're going to do the point 0, -4. It's going to be open. 1, 2, 3, 4. It's going to be open. And then another good point is going to be point 3, 0, 1, 2, 3, 0, like that. And I would just go through those 2 points and just make it the best you can. Like that. Okay, so that's your graph. I wouldn't worry about trying to graph the thirds. If you want to do that, feel free to. Okay, so this one, I'm going to graph the line y is equal to a -3 for values x is less than or equal to 3, so it's going to be a solid point at that. So I'm going to go ahead and do that. That's pretty easy. Okay, so -3, 1, 2, 3, and I'm going to go over to 3, 1, 2, 3. Okay, so for values x is less than 3, so I'm going to have a close point, and I'm going to have a straight line that looks like that. Okay, so it looks like that. Now I'm going to take my t-chart and I'm going to build it for the other portion. Okay, so I'm going to start at 3. Okay, so I get 3, 1, 4, 3, 5, 5, 6, this should be 7. Okay, so I'm gonna have an open point because there's no equal to sign. Okay, so the point 3, 1 is right there. You have an open circle. Okay, 4, 3 right here. So it looks something like that. So that's what our graph looks like. Okay, we'll have a jump discontinuity right here. Now sometimes they end up lining up. I mean, it's not a big deal if they line up. That just means the limit exists. Okay, so onto the back. Like we did on last set, we have to decide which branch we're going to be in. So f of 1 is going to live in the bottom branch. So negative 2 times 1 plus 6 is equal to 4. Okay, f of 0. 0 is going to live in the top branch. So 4 times 0 plus 5 is equal to 5. F of negative 1 is going to live in the top branch. So 4 times negative 1 plus 5 is equal to 1. F of 6 is going to live in the bottom branch. So negative 2 times 6 plus 6 is a negative 6. Now I want to evaluate the limit as x goes to 0. So we have to do the left-hand limit and the right-hand limit. Okay, and this is all in preparation to do continuity. Okay, so the limit as x goes to 0 from the negative side is always going to be the left-hand branch. So if I plug in a 0 into the less than branch, you should get 5. Okay, if I plug it into the right-hand branch, which is always the greater than branch, I get 6. So that means that the limit as x approaches 0 of f of x does not exist. Okay, so if the left-hand limit does not equal the right-hand limit, then the limit does not exist. Okay, so that's been graphing piecewise functions. Set number 2. Make sure your graphs and your homework questions are nice and neat, as neat as possible. Thanks, and have a good night.